Welcome back. Next keynote speech is from Professor Nong Zhang, co-chair of ICAVP2021 Hefei University of Technology. Professor Zhang received his BE degree in 1982 from Northwestern University, ME in 1984 from Shanghai Jiaotong University, and PhD in 1989 from the University of Tokyo. He worked at several universities in China, Japan, and Australia, respectively, before joining the University of Technology Sydney in 1985. From 2016, he held a professorial appointment and the position of Director of Automotive Research Institute, Hefei University of Technology. The topic of his keynote is study on extended range electric logistic vehicles and application examples. Let's welcome Professor Zhang.
Thank you, Professor Xu. Thank you. Okay, good morning, everyone. First, I'm very happy to attend this conference and to have this chance to give you a brief report on what I have done recently. From my background, as you can see, I'm actually a traditional academic. However, in past few years, since I came back to China and worked with many industry partners, and I find actually in China, when you try to apply some good technology to the real vehicles, there's a lot of engineering problem, and also cost issues, so on and so forth. So my research interests and also my focus gradually shifted to how can I, in a best way, to apply for the technology to the real world, say, vehicles, and to meet the industry need. So today I'll give a brief report on what I have done, and I'll also share with you of my reflections from my work. Okay. The content of my presentation includes 5 parts: background of research, and the review on the extended range electrical logistic vehicles. And the third part is case study 1 about an extended range electrical logistic van, and also fourth, briefly talk about a new engine we call cyclic engine, which is very good for range extended system. Finally, I'll give some concluding remarks. Okay. The benefit of electrical vehicles, I guess, for us, everyone probably already know. This data, as statistical data, I try to illustrate not just the passenger car contributes the emission, the CO2, or particles. Actually, the commercial trucks, vans, probably in a way contribute more the emissions. If you look at this is in terms of CO2, and currently we are in this line, right? So passenger cars still contribute a lot, but if you look at the red area, this area, the commercial trucks and buses control equally around the commercial the emissions, including CO2 and the harmful particles. So if you look at the next few years, like 5-10 years, because of the electrification for the commercial vehicles is widely sort of applied, so the contribution of the commercial vehicles, the passenger cars to the emission is reduced rapidly. But commercial vehicles, not so. So from this, we know in order to really effectively to reduce the emission, especially the harmful particles, actually the electrification of the powertrain of the commercial vehicles is essential. Okay, so I'm not going to talk anymore. But this data also can show you some evidence. We always talk about when you try to apply a new technology, you need to spend money, and you also need to find the customer. Now, what will be the market is concerned? Let's say traditional internal combustion engine vehicle. Range is good, efficiency is not so, performance is good, but if you look at the battery side now, what the problem is, as we know, the emission and problem, right? So this is not good. But battery electrical vehicles, range not so good, efficiency probably you can say is good, but performance was good. However, you have a problem is battery size and life of the battery, cost. Then you say, okay, let's use parallel, series, hybrid electric vehicles. If you look at all these, okay, battery size it can go down, but the cost-wise, you need to have more motors, and performance-wise, you have a problem as well. So what is the best? I try to say my bit. Look at this. Range extended electrical vehicles. You can cover the need of the range. You can have a very good efficiency of the engine because you always can run your engine at the best sweet area. And performance-wise, depends how much money you want to spend. You want to spend more money, use a larger motor, larger battery, or larger engine. You could get the performance one. Powertrain capacity, simple. Pure electric drive plus like a battery charge package, right? And electrical motors, yes, we do need 2 electrical motors, but in transmission, we don't need any more transmission. So overall, the battery size can be small. So from this, you will see naturally the extended range electrical vehicles probably is the good solution, particularly for the electrical logistic van or trucks. Now, first, if you have a range extend system, you can reduce the size of the battery very significantly. And also, because you have an onboard charging system, you can actually supply some electricity directly to the driving motor. Then you can actually reduce the demand of electricity demand from the battery. You can actually help to enlarge it, like make the battery life longer. Okay, so it's actually good. Now, for in the range extend system, this is a range extend system for the powertrain. You have an engine, driver, and generator to generate the electricity. That electricity can be sent to your driving motor, or you can send to your battery to charge it. Logic is quite simple. Okay, what is the advantage of the range extended electrical logistic van? Let me read it through. Acceptable driving performance, good and excellent engine efficiency, and a small battery size and simple BMS. The battery management system can be quite simple. And good and desirable driving range, especially refrigeration needs. Don't forget, commercial vehicles, you transport food, medical equipment, medical sort of medicine. You need to have refrigeration to keep the goods safe. So, second, if for the refrigeration, there's the demand for the electricity, right? Okay. Then low fuel consumption and operation cost, and also other costs. Simple powertrain configurations, low development cost, and your range extend system is reusable. Even your vehicle is run down, but the engine, the motor, you still can use. Lots of benefit. Then what do we need to do to help our industry to actually use or to apply the range extender system? Here's a few points. First, we need to know in which sort of balance you keep the battery size, electrical drive mileage, and what size you need the capacity of your range extender system. The balance for these two parts is an issue we need to understand. Second is that we also need to do the research to understand what is the optimal main component size, because it's not the larger the better. It's cost. You need to really consider the cost. Okay. So then third, the major component is a range extend system, which include IC engines, generators, and integrated thermal management system. These three parts actually is not same as the traditional vehicle. Why? The engine is, you don't need the engine to run at a very wide speed range. You can run the engine at a narrow speed range, as long as its efficiency is the best and the emissions levels, right? And you can make your generator, and also you can design your thermal management system for your range extension or integrate it into your vehicle as a whole. Then the last one, the highly efficient and cost-effective powertrain. If you look at the slides I told you before, you may achieve really high fuel efficiency and maybe even low cost for your powertrain. Okay. Main energy management strategies. Well, basically, this is the work we did in 3 years ago. We actually did a lot of literature survey. My PhD student read probably about 200 papers and reports. We found can be summarized the energy management strategy mainly is say 4 categories: closed loop control, fuzzy logic control, and forward claim control or cup table. And these you can find these references from our paper. So I'm not going to talk the details. You can read it. Now, control logical diagram. Say you have a vehicle situation, load situation. You given a speed target. Then the vehicle decides how much power you need for the driving motor. That command, that like instruction or demand, sent to your range extend system or to your battery. Come back to is one part of the power is from the range extend system. Another part of power is from your battery, and these combined and to send to the driving motor. And it's very simple, really. There's no comment. Then you say, well, that's the power flow. Let's see the control logic is behind this. Well, say while drive cycle depends on the speed demand, you have a power. Then the power requirement sent to the energy management system is tells first see your battery situation, the state of charging. If, say, the state of charging is larger than, it's less than, say, 45%, then you say, well, you can't use continuous drive mode. You need to turn off and turn on. You need to turn on the range extend system to charge the battery to supply the power, vice versa. So you come to here, so you can see if this is called engine on mode. Basically, it's charging the battery or driving the motor. So this is integrated need of the demand from your driving motor and the battery. You need to consider the battery situation, the state that we call state of charge. You need to consider that. Okay. About the charging, there are mainly two range extend system charging strategies methods. So one is called power flow method, another is optimal range method. powerful method is relatively simple, but not as efficient as the optimal ranging method. Optimal ranging method probably is more complex. You need to do a little bit more pre-development to make it work properly. So again, I'm not going to go to the details. If you like, you can find these references and read the report. In order to further improve the efficiency of the whole power train, you can also have we call hybrid energy storage system, which include normal batteries plus a super capacitor. Now, these combine the energy density for power density things. If you want to maximize the regenerative braking, you need a super capacitor to receive the larger current electricity, right? So these are 4 possible combinations of your hybrid energy storage system. Okay. Okay, so this is a brief introduction of the range extend systems, the advantages and the disadvantages or some issues, the existing issues we need to overcome. Now, what is the problem? Say if the range extend system is so good, why is not widely applied to the commercial vehicles or passenger cars? Actually, passenger car now successfully is Li 1 is very successful for passenger, which is the electrical vehicles within the range extend system, lithium. So you can see plenty of successful examples. In Japan, the e-power vehicle is also a very good successful example. But for passenger cars, it's already you can see these very successful applications. But for the logistic vehicles, we don't see many yet. So what were the problems or issues? In my viewpoint, the first part is the coordination of the range extend system and the battery systems, and that still is we know what we need to do, but in a way we do not have any in-depth or very experienced sort of understanding of the needs of this, right? So we need to do more research and work to get a better understanding of this part. Second is the integration of the thermal management system with the range extender system and the vehicle and the hybrid energy storage systems together still is needed to be further researched. In theory, it's possible, but we haven't done enough work to do that. And also, we talk about when you use a range extend system, you need to have a compact, low weight, and high efficient IC engine. And also, this engine needed to be using clean fuels, gasoline or gas. Don't use diesel, because diesel produces harmful particles. So you need this. Now, you say engine, we have been developing research and developing engine for a couple of 100 or 200 years. But why do we still need to do research on IC engines? This engine is unique. It's not really for direct drive your vehicle. It's only for charging your battery or to supply electricity to your driving motor. So the definition of your engine is different from traditional engines. So you do need to, how can we develop the best engine for range extend system? So this is a research need. And also, noise and vibration issues of the range extend system. Because you do have an engine, motor, that will generate vibration, noise, how can you handle it? Yeah, these things need to be looked at. The next part is I'm talking about case studies. My PhD student did a simulation work based on a very typical logistic van, which is vehicle mass is 1.58 tons, and the gross weight is 1.4 tons. Altogether, it's 3.2 tons. It's, then, if you look at this radius, if you look at this, we say, okay, we put we add a range extender system powered by a small engine with 35 kilowatts power. Let's see what result we'll get. So, based on the battery model and traction model, the energy map of the traction motor and the engine mapping, and then we can start to do some the energy management system, optimization. In this case, we use employed energy management method is use dynamic programming optimization. Probably most people know that, so I will not go into detail. Just see the result. As you can see, if we use a driving cycle is CLTC. When battery is still fully charged, we use battery more. But when the battery, like a state of charge getting low, and we use more range extender system to generate the electricity. The green part is the electricity you draw from the batteries. Red part is you get the electricity from the range extender system. If you when the SOC is become lower, then we start to turn on the range extender system more often and working more. So you get more electricity from the range extender system, right? By doing so, you can see actually, if you look at the consumption of the fuel, this is the diesel fuel. For range extender, like extended range electrical logistic vehicle, the battery size 20 kilowatts, and for the battery electrical logistic vehicle, the battery size is 60 kilowatts. Same 2 driving cycles. We did some simulation, shows, okay, when you use pure battery electrical vehicle, yes, your efficiency-wise is good. However, your drive mileage is low, only up to, say, 156, and even another case is even worse for driving cycles. However, for extended range electrical vehicles, your fuel consumption is not so bad. Every 100 kilometers is about 8 or 9 liters, but you can drive range up to 550 or 600. Big difference, right? Then you look at the cost-wise, because in China, the cost of a logistic vehicle is very sensitive and very important. Actually, very important. The customer always pay attention to the price of the vehicle and also the running cost. So you have to make sure the vehicle you produce is at low cost. People can afford to buy it, can afford to use it. Then we did an analysis over life of the vehicle. If you use internal combustion engine logistic vehicle, say when the fuel price is lower fuel price, high fuel price, the price overall of the vehicle is between 78,000 to 85,000 in this range. The price of the vehicle, including your purchase sort of price plus the use of the vehicle. This is in US dollars, okay? In US dollars. Now, for battery side, you get 82, 83 in between. For extended range electrical logistic van, you actually get the price range is 73.5 to 77. So even for highest fuel price, this number is still lower than the pure electrical vehicles. That means even for price, when you use a range extend system, that vehicle overall the cost is lower, the lowest. Now, this two figure tells the life, well, how, well, basically the plot of the price of the vehicle. Okay, for instance, if you look at this, say for vehicle total around 250,000 miles or kilometers, for that usage initially, this is a IC engine, and this is a range extension vehicle, and that green line is the battery electric vehicle. Initially cost is the battery vehicle is highest, and the range extension system is the second highest, and the traditional vehicle is lower. But when you go through when you use it for a period of time, you can see the cost of the traditional vehicle is going up. And for the battery side, up to one stage you have to change the battery. That will give you a sudden increase of the cost of your vehicle. Only the vehicle with a range extend system is continuously going and keep going, and the cost actually in the end is lower. Keep in mind, even your vehicle is say run down, you want to change a new vehicle, but the range extend system is reusable. The engine generator is reusable. Okay. Oh, sorry. Well, this is for lowest fuel price, for highest fuel price, and you can see the traditional vehicle going up a little bit higher than the battery vehicle. But if you use the range extend system, it's still lower than the battery powered electrical vehicles. Okay. Now that's case study 1. I will present case study 2. You told me one more point we missed is if we say the extended range system is good, then you ask why people don't use it. Why do people don't apply it? There is a problem. Everyone says, how can I get this such an engine? Who can supply the engine to me? Not many. Now, say, what is the best engine for range extend systems? In my viewpoint, first, the engine has to have high fuel efficiency, lower emissions, which is CO2 and harmful particles both. And the engine has to be small size and low weight. And the engine has to have excellent NVH performance characteristics. And so also engine has to small vehicle chassis packaging. Means you have to small enough you can accommodate or packaging it into the vehicle easily. And low maintenance cost, for sure. Everyone loves that. Low cost in simple powertrain integration, low development cost, reusable range extension, blah, blah. Why I'm putting this as emphasis? Because the logistic trucks and vans, the vehicle, the manufacturer, the OEMs, they do not have manpower or resources to develop their own electrical powertrains. So because they simply can't afford to have a larger development like a research center and to do that. Passenger cars, yes, they can because they have a larger volume of cars. But for commercial vehicles, they don't. So who will do that part for them? So this actually is a real cost. So if you can integrate, if you can develop an easy, like a simple engine, simple range extend system, can put this system into the vehicle easily, every OEMs of the logistic trucks and vans would love it. I'm very sure. So what is the best engine for this? Now I would like to introduce, it's called Cytec engine. This engine is initially developed in Australia. Recently, a Chinese businessman bought the IP and to redevelop this engine for range extend system. we call it Cytec engine. But actually, the engine is not like a traditional engine. The engine uses Scotch yoke mechanism for the translation between linear motion and the rotation. This engine has a few really good sort of a feature which we do want for range extender system. Okay, first, we do not use the crankshaft, conrod, piston type of structure. We do not use that mechanism anymore. We use Scotch yoke mechanism to translate the piston linear motion into the rotation of the crankshaft rotation. You will say, Scotch yoke mechanism is an old idea. Why you use it now? Yes, it is an old idea, but so far there is no good idea to design the bearing to make this work. So this Australian company, now is a Chinese company called Cytec Technologies, they invented a special type of a slide bearing. That slide bearing can provide enough sort of a lubrication to make the linear motion translation, couple these motion together without overwear, without frictional loss, too much frictional loss. And why this engine is good? Because the Scotch yoke mechanism, they made the linear motion, the conversion from linear motion to the rotation is a perfect sine wave motion. So made this, when you fire your engine, if you use this crankshaft piston, the traditional engine, you actually hear the shape of that sine wave is very sharp, quick rise and very rapid drop. That is not good for combustion process. So if we use this mechanism, you actually made this sine wave, so you have enough time to get the fuel mixed and burn, so you get better fuel efficiency and less locking. Also, because it's horizontally positional pistons, and then you have two cylinders of like a traditional four-cylinder engines. In this length, you have this size, but when you use the Cytec engine, you actually cut this size in length for half, almost half, a little bit larger than half. So size-wise, very small. Of course, you can develop a 2 cylinders, 4 cylinders, and 6 cylinders engine, modularize the engine development. This company also contracted to FEV in Germany, helped to made the conceptual engine and the first generation, second generation. Currently, is the second generation engine is in the assembly process, and the planned testing is by November this year. We will get 4 sets of testing result for the engine. So I'm not going to go to the details. I just give you some boundary condition for the engine design. Basically, we say, okay, engine can be designed, can be 2 or 4 cylinder engine. Basically, we try to less than 1 little capacity, because in China, some government regulations, a small engine defined by, if you have a engine volume less than 1.5 is a small engine. So we want to control the engine within this range. The engine has to be able to achieve China 6B emission requirement. And the rated power can be 30 kilowatts or at 4,500 RPM, or can use, say, 92, the long 92 gasoline. And the engine can achieve good fuel efficiency. Also, the engine's firing order is different from the traditional way as well. You need to really redesign the engine. So this work was a contract to FEV, and FEV did that for us. This is recent, like in the first half of this year, the FEV got the simulation result for we call it S415TC, which is 4 cylinders, 1.5 plus turbocharged. And the efficiency-wise, this is an engine without any additional technology like GDI or this is only root engine. They get the simulation result. Just look at if you look at braking torque, and you get the fuel efficiency, you can see when you use say 98 around 98 fuel, you get very good fuel efficiency already. Of course, if you use poor quality fuel, you get a poor fuel efficiency, but still, it's a good size. One more engine we actually already developed, and the first generation engine is 415 NA, natural air without the turbocharge. Okay, for 1.0 engine running at 45 RPM, 4500 RPM, we can get 62 kilowatts power. And FEV is quite sure their simulation result with compared to the test experiment is only maximum is only 3% difference. So can meet China 6B requirement, and also the fuel efficiency can control under 229 gram per kilowatts hour. Okay. The size of the engine, you can see this is currently very compact and small, and we can develop a two-cylinder engine, natural air, NA at 30 kilowatts, and the four-cylinder engine without turbocharge 62 kilowatts. If we add a turbocharge, we get 110 kilowatts power. Quite a powerful engine. Okay, so if we look at this, so far the engine does not require. Okay, you may need a turbocharge for increase the power. We do not need to use VVT, do not use EGR, and even GDI. So a lot of things we don't need to use it. Very simple, cheap. And the engine is smaller, lighter, shorter, cheaper, and with very good NVH performance. Very quiet and small vibration. Okay, based on this the small engine, we did another simulation, quick simulation, just check if it is good, better than the other engine. This is a BSFC for this engine, and also we use this fuel efficiency as indicative of engine's fuel efficiency. We did a simulation to see what is the cost for an electrical logistic event. This is the result. We show you the state of charge variation and for the range extender system for the driving cycle. This is driving cycle WLTC. That's driving cycle for CLTC. This is our worst driving cycle. You can see. Yeah. State charge. And this is the result to show you what is the fuel efficiency of this vehicle. As you can see, for this worst driving cycle, we get first 100 kilometers, you burn about 8.3 liter fuel plus 45% of battery electricity. 200 kilometers, you get a little bit quite more of that. For this driving cycle CLTC, the fuel efficiency is better because the driving cycle is different, right? Okay, so everything data is there, and then let's see the cost. Okay, this discussion, the data already shows that. We also did a similar cost analysis. For a similar vehicle, if you use a traditional engine, then the vehicle cost will be, say, $84.5 thousand US dollars. For battery electrical logistic vehicle or van will be $85.3 thousand US dollars. But for this new vehicle, use the range extender system plus the electric logistic van. The overall cost is 71,000 US dollars. How much reduction of the cost? Nearly, compared to that, nearly 20% of the cost reduction. Very attractive, right? That's the actual data show you. Again, this blue line is the extended range electrical logistic vehicle or van, the lowest cost in the end. After you drive the vehicle for 250,000 kilometers. Okay, so my last part is to give you quick conclusion remarks. You may not agree with me, then please do some research, development, let's argue. Okay, at the moment, this is what I get from my result. First, I would say electrification of logistic trucks and vans is also essential to emission reduction and fuel economy. Don't always pay attention to the passenger car, please. And then cost effectiveness, we call total cost of operation. In terms of purchase, operation, maintenance, and retained value extra, need to be looked at also, because for commercial vehicles, that is really sensitive for customers. So, extended range electrical logistic trucks vans offers a realistic and optimal solution. That's my opinion. If you don't agree with me, show me your data. Then, specially design. The fourth point is specially designed engines, such as Cytec engine, are very suitable for range extender system applied to the electrical logistic trucks and vans. Why? You can produce in volume, different by modulation, you can different size, and very small, easy to integrate, to be integrated into the vehicle. Last bit, development of the low-cost range extended system and the simplified application to the powertrains of various electrical logistic vehicles is also important. I just discussed this with Professor Xu. He agreed with me because in China or elsewhere, the OEMs of logistic vehicles, they do not have large team of the engineers and test equipment to develop this. So we have to make this simple, cost effective, low cost. So that's my concluding remarks, and I would like to thank my colleagues for their help and contributions, particularly my PhD student, Boyi Xiao. He still is a PhD student of University of Technology Sydney. He probably will graduate by end of this year. And also my colleagues, Mr. Lin Yang and Mr. Richard Tamba of Cytec Powertrain Technologies in Guangzhou, China. And also, I would like to thank the engine development team of FEV Germany. They did a lot of excellent work for us. Thank you for your attention. Thank you.